All right.
There we go.
Test.
Okay, thank you everybody for coming. While everybody gets a seat, just a quick show of hands. How many are here visiting San Francisco? Amazing. Very quickly, where are you coming from? I know Australia. Where else? Los Angeles, Spain, right? Anybody else?
Germany.
Germany. Okay, there we go. South Bay. There we go. South Bay is a big one.
One more South Bay.
South Bay. That's a distance. So thank you for coming. Another show of hands. How many here are with a startup that has yet to launch anything? Amazing. Just one? Nobody else? Two? There we go. Okay. Three. Good. How many here are at a company that launched something in the last month? Excellent. More. So I expect a lot of questions because this is a very active space, right? My name is Manolo. I'm based here in San Francisco. I work with ai-coustics. I'm going to be your moderator today. We're going to keep it conversational. It's a nice small group here. Allows us to do that. I will ask at the beginning, and I'll just do this before we get into the panel. Are there people here that are looking for one of two things? I've done this at other groups when I've done it, when it's been small. And just to be able to kind of capitalize on kind of the positive energy we got. Is there anybody here that's either looking for a job or looking for a team? There we go. Stand up. What are you looking for? Amazing. There we go. Excellent. Thank you. Anyone else? I had warned him that I was going to call out over there. Anybody else? Excellent. Okay, here we go. So the way we're going to do this, I'm going to ask our wonderful panelists here to introduce themselves. We've got about a half a dozen questions. We're going to do this for about 30 minutes or so. We're going to open it up to Q&A after, of course. And making it very collaborative, I'm going to ask the panelists, and as well as you all, when you ask your questions, is to try to ground it in stories, right? There's a lot of voice events going on this week, so we really thank you for having chosen this one. This is our first one as part of the what we're calling the voice layer, the audio layer. The audio layer. Thank you. It's the first one, so we got to get that name right. So let me start off by asking our panelists to please introduce themselves.
Atila, founder of Argmax. We're not going to do voice, actually, when we started. It's an on-device developer platform for deploying any model on device, literally. But we think speech models are very ripe for on-device deployment without any compromise on accuracy and gain latency, reliability, all that stuff. So that's why we're here. We work with healthcare companies. We work with, blank companies for real-time speech products. And we build an SDK.
Everyone. I'm the founder of Coval, and we build simulation and observability for voice AI applications. So really helping you to scale to production, make sure that you're compliant, that your workflows are working as intended, that your agents are staying on track. My background's from Waymo, so I led our evaluation infrastructure team at Waymo that was responsible for all of our developer tools. And now we're taking all of our learnings from autonomous vehicles and building that for autonomous voice agents.
Hey everybody, I'm David, a founder of LiveKit. So LiveKit is a developer platform for building voice AI. And if you're a builder and heard of LiveKit before, you should probably check it out. Take a look.
Cool, thanks. My name is Fabian. I'm one of the co-founders of ai-coustics, and we're developing technology to fix the audio input for voice AI and voice agents. Part of it is removing noise, but also there's other artifacts that can happen to an audio signal. People being too far away from the microphone, distortion, clipping, being in a very reverberant room. All these kind of things often don't help with things like, what error rate or voice activity detection and some things. So we develop models that can actually improve this and then improve sort of like any type of downstream task in a voice stack, I would say, in the beginning to improve things like, again, voice activity detection, what error rate to make voice AI applications, and I'd say voice agents just more robust to the real world. Yes.
Okay. And just double check. Can you in the back hear us okay? Excellent. It would be embarrassing for an event like this that we don't have good acoustical properties down there. Okay, so let's start off with the first question. I'm just going to ask all of you to contribute. We'll just go one by one here. A panelist at a recent event argued that no voice AI experience today works as intended. So here we are, end of 2025. No voice AI experience today works as intended. Do you agree? And which parts of the stack most often cause real-world failures?
Awesome. Right. I'm pretty sure there'll be a lot of agent talk after me, so I'll do a non-agent talk. As far as use cases go, we focus on ambient use cases. So think about meeting notes, medical scribes. There's a conversation in real world or in a virtual like Zoom setting. And there are a lot of emerging use cases for transcribing that conversation, detecting speakers, and actually deriving insights from that conversation, be it follow-up action items in a business setting, be it actual EHR entries into a system in the medical use case. So we focus on that ambient use case, and taking off-the-shelf models has I think it's relatively easy to build a demo and launch a proof of concept. For a lot of the winners in the space actually take modeling in-house and try to build vertical models, as in like if you build a speech-to-text layer, can you make it such that it understands your vertical so well that that's part of your like technology moat. I think without pulling modeling in-house and integrating into your vertical, like using off-the-shelf third-party models is not going to cut it for these use cases. And we see context engineering as well as like model engineering for high-value use cases to be, I think, the difference between catching like wildfire inside an organization when you make a sale, having actual adoption, because you can sell into enterprise, but if the users are not adopting it, you're not going to be able to monetize that deal. The ones that actually do catch fire inside the enterprise after the sale happens is where you have this vertical specific kind of accuracy boost.
Yeah, I think the question is not if agents fail, but when they fail. And I think really thinking about it from the perspective, at what point, what is the probability of success of my agent and what is the acceptable probability? So in self-driving, the way that you think about this is like how many events per million miles, per 10 million miles, per 100 million miles. And you're not saying that this thing will never, ever happen because they're non-deterministic models and you're dealing with the real world. But you instead look for like, what is the level of risk that you're looking to take for any given type of event? So maybe there's things where it's just like slightly uncomfortable. Maybe it is like a bit jolty in the car. And the equivalent in voice is maybe you have like the agent has to repeat itself. And then there's other types of errors like, maybe you reveal the SSN of your banking customer that you don't want to, that's a, 1 in 100 million mile thing that you want to happen. And so I think really thinking about what is the probability of success versus this test passes or fails. And then I think to the point of do agents work in production? Certainly there's enterprises that are scaling them and I think voice is really exciting because it's the industry where you're seeing the most adoption of truly autonomous agents in the enterprise for real cases facing customers. So certainly there's agents in production. And I think that is like the exciting take is how do you scale it to 10 million conversations, 100 million conversations and make that work really well?
Yeah, I totally agree with that. There's a lot of resemblance to autonomous driving in Q, right? Because a lot of times, because these agents are actually doing the job of a person, sometimes whether it's answering customer service calls or booking a reservation. They're multi-turn, right? So they're not like an LLM that assists you with coding. You're like asked it to do something and it does it. You're checking the results afterwards. There's nobody to check the results of these agents. Right on. So I think, do they work or not? They definitely work. I mean, we're seeing the scale from customers. There's tons of businesses that are succeeding with these things, but the next question is like, for what? So generally what you see, I think we're so early in this whole wave where people are really trying to put like the use cases that are like most has the highest tolerance for failure, right? First, like things like debt collection. If somebody is not paying their bill, I'm gonna, do I want a human to spend time to call them, or should I get a voice agent to do that? And you can really measure these things, look at the results, like, is it successful? Sure, they don't always work, right? To Manolo's point, they probably have a higher failure rate, but sometimes it doesn't matter initially, right? And so you deploy for these use cases first. As your agent gets more reliable with the help of Coval and other solutions in the space, you can kind of increase that reliability and start to put it to more and more use cases. So, but I think, we're just super early in this whole journey.
I can probably comment a bit again on the input side of things a bit more. So, I guess we see a lot of like failure and breaking points when, for example, you have an audio input and then there's a conversation in the background that's being like picked up, and then either it stops basically the agent because he or she thinks that it's being interrupted by the caller. Sometimes the background's being transcribed, all of these kind of things. And I mean, I think it's my favorite example because it's so obvious. If you test, your system in the lab, and then, for example, you have a voice agent that's like, a drive-through kind of situation where I imagine, someone with a, Dodge Ram car, whatever, comes in, it's very loud and, 2 meters away from the microphone there. I think that's just very different from the lab environment, maybe where you've tested it or something. And I think that's probably, that's a very obvious, I feel, example of a breaking point. But whenever lab conditions are testing conditions in that sense are very different from real life conditions, then there's breaking points.
I'm curious, Atila, if I could follow up with you. So David used the example or said that you try to find those cases where, I'm going to paraphrase it, but where failure perhaps or the tolerance for problems is high. In your case, which ones are those cases?
Ooh, that's hard.
And it may not be because you're in a slightly different world.
Yeah, I think in a previous life, by the way, I was doing computer vision, and like calling a cat a dog was fine. So like along those lines, I'm just trying to think back to the voice space. I think it's a matter of churn, to be honest. Like, for example, one use case is personal voice dictation apps, because Apple's like first party dictation sucks. So there's a lot of third party extensions people use. And if it gets what you're trying to say, like, for example, you self-correct, you stutter, you don't properly pronounce, but it has the context to disambiguate and all that stuff, it's surprising and delightful. So it will improve retention. But even if it doesn't do that, you may cut it some slack because you messed up when you were doing the input. You were trying to yap and the input wasn't perfect either. But if your competitor is doing better in terms of like context engineering and like disambiguation, then somebody else will have that user. So,
and it brings me to the next question. And this is the idea of, are users expecting too much? Right? Or is tech still too far behind? So if you think about it, we're wired for conversational flow, right? We naturally expect a certain cadence. We expect a certain amount of contact that then gives us signals. Are systems failing mainly because the tech isn't close, or because the expectations are impossible to meet? Right? And that goes across agents, meeting assistants, scribes. Just curious. And I know I'm starting with things that look like negative. I'm going to bring it back up. But we started in 2025 with a lot of things, a lot of promises that 12 months later, we've checked off a lot of boxes. So I want to go through that.
Yeah, I think kind of to address the like two last points. Oh, sorry.
You go first.
The two last points is, I think really it's about like, how do you design systems that are fault? Maybe it's not that you even get in order to get the success that you need for a certain use case, it doesn't necessarily look like guaranteeing that at runtime. But there's lots of cases, like if I'm required to report something after a customer tells me about that report as per regulation, maybe your voice agent fails to do that at runtime, but then you have a script that goes through and says, for all the failed cases of that, I want to remediate that same day. And so you're still within regulation, but maybe you're still a bit more fault tolerant. And so I think people need, like, thinking about what are the fallback options and how can you design voice systems in more like native ways where even if your TTS system does fail,
Or a microphone fail.
even if your microphone does fail, that you're able to like either have fallback systems, which like LiveKit does a really good job of. You can just like be able to enable fallback mechanisms. I think with Waymo, like there's all sorts of fallback mechanisms. You don't even have one, but you actually have many fallback mechanisms before it pulls over and stops. And I think the equivalent in voice is, how do you create a fallback mechanism for your app that's context specific to your product?
Yeah, and I guess it's also a bit like about, the expectation you have versus these like systems. I don't know, if I remember my last like interactions with like, a normal call center, like I'd say there's also a vast like difference in experience I probably had. And by you guys nodding, I think you had the same. But there is already, I feel some like really superhuman capabilities of these systems. You can technically, you can talk to them like 24/7. You can also talk to some of these systems in like 10 different languages. Try this with an actual human being on the other side of a call center. And then, for example, I don't know, like some speech-to-text systems. I think the largest Whisper model, for example, I remember there was some audio files I analyzed once, and I couldn't hear anything that was said, but, Whisper would get actually the transcription right. And that's kind of like already towards like, I would say a superhuman, not accuracy, but transcription in that sense. So I think it depends a bit on the expectation, but there's already some parts of the systems that act very well when it comes to sort of like how we sort of have a normal conversation and the flow. There's probably some improvements still to be had. There's other aspects where I think we already have superhuman or kind of superhuman systems.
I don't think users are expecting too much. I think, the tech needs to get there, right? Like this is the whole reason why people are really excited about voice AI is that now for the first time ever, like the computer is moding to how we communicate. We're not moding to how the computer works. It's all the way around. So whatever we expect should be how the computer should behave. And it's our job to get it there.
I do have an interesting take. If the baseline is human performance, then it's a matter of like, is the system already beyond human, but we're just evaluating a non-human system, so we don't know what the baseline is, and like we're saying anytime it does something wrong, like we don't necessarily think like would a human level performance, right? So I think a good example is like how many people use AI meeting notes, like when you got into like Zoom meetings, etc. Okay, cool. Right. So you are aware of like, I don't know which, depending on which flavor you use, there's like a system audio where everybody else speaks and then that's bundled into one transcript and then you speak, that's the microphone stream and like that's your speech. The ideal use case, like all the end users are asking for every speaker to be separated and properly attributed. So if somebody says something, it's like attributed and then follow up action. But if you just listen to a meeting without any context, like you don't know anyone, and just all of a sudden, and people start speaking, if you close your eyes and try to listen to the meeting, it's almost impossible for you to diarize it or attribute the speakers properly, unless you know what someone would have said because you have like textual context from prior meetings, or you have visual evidence because you see someone speaking. So when it comes to human level performance, I think some of the expectations from like voice systems, especially for speaker attribution in our case, is really high. That's why even if you get someone to like try to do it for you instead of the machine, and the system is better than that person, it might not meet user expectations today.
Disagree with that. Like, we've been doing conference calls for decades before video was a thing, right? Like, people figured out who's speaking.
People figured out who is speaking, know who is attending the meeting, and who they know what each person is likely to say. If the only evidence you have is audio without context, that's
We should try it. I bet I can figure it out.
Do you want to be our baseline?
Yeah, I'd be happy to be the baseline.
I'll come up with a challenge for you. Sounds good. Because I tried this literally. I think back to podcasts where like the first episode I listen and I can't make out who the speakers are. And this is the all-in podcast. And like after the 8th episode, I start getting like, okay, this guy is speaking now. But then if I listen to a few episodes, I know what people are likely to say or like how they speak. So it's beyond audio that you need like context for to be able to do this. I think.
Yeah, that's definitely true. That's something that I think voice AI agents are kind of missing right now.
Right.
Like, how do you engineer that context back into the agent?
That was great. I like that. Thank you for the examples there. Moving on. So we all aim for consistent performance. That's what we've been talking about in unpredictable environments. That's really the heart of today's conversation. So I'm going to ask for one customer story from each of you where the real world setting was so challenging, where the voice AI system broke, right? That it forced you to change how you built your product or service, and how basically customer feedback really helped you, shape that evolution. You have many, I am sure, because that's what you do. So why don't we start off with maybe Brooke?
Yeah, happy to go. Well, I guess from how we've learned about our customers is probably, we're probably more on the other side.
Right.
But definitely, I think one learning from our side is just how complex the different testing capabilities are. So it's one thing to say, like, I want to be able to handle refunds. But in reality, like, we primarily work with Fortune 500 enterprises who are scaling their voice agents to lots of complex use cases. And I think I've been astounded by just how many, like, I'm sure you guys see this all the time, is like thousands of pages of standard operating procedures, like thousands of different call flows that you can go through, like IVR trees that no one really can map out. And so I think really what we're trying to do is operationalize when you have these really large complex systems, how do you basically create a CI/CD pipeline for non-technical people, like an operations platform to be able to see. And so that's definitely where I think we see customers fail, is when you have lots of different workflows. Each one of them works fine if you just try to implement one. So if you just tried to implement refund, or if you just tried to implement, like, I want to reset my password, but as soon as you start to scale to thousands of use cases, being able to handle that context, do intent recognition, be able to, like, there might be like 2 different workflows that are very similar, but one is for like international and one is for domestic. And so your agent has to be able to determine like which is. So I think just the sheer complexity of so many business use cases, I think we're still very early in voice, but we're going to see that continue to explode in terms of what we expect voice agents to be able to handle. And then I think background noise just continues to be like someone talking in the background. I'm calling from the street. Like, no one is in a perfect, like, meeting room-esque sounding place.
Yeah, that's the answer, that I would have given, of course. One of the use cases I've mentioned earlier, which is a drive-through. We had another one from someone like a veterinarian kind of clinic, and it turns out any room they were ever in sounded like, a bathroom with like maximum reverberance. So kind of like, not really like a church in the how you say the size, but if you've ever recorded something in a bathroom, with like completely solid, non-absorbent walls, it just sounds horrible, and there's no like direct sound anymore. So this is very difficult. It's probably something that, not sure if the ASR providers train for that special use case, but that was sorry? Calling, maybe, that that's probably what people do. So yeah, that was one, I don't know, another example of a breaking point, a very, very reverberant room. But yeah, generally, like, I think acoustics itself, so like, the whole signal path from like someone speaking into a microphone, then afterwards, so like there's a speaker, there's a path towards the microphone with some reflections. The microphone itself has some kind of like, impulse response or device of like frequency pattern in that sense. Then there's some like signal processing afterwards going on. There's maybe some like clipping, there's codec compression, then it runs through like WebRTC. Like it's a fairly long signal chain now, if you really think through it, from like, the analog world, then ADC conversion, and then even on the digital domain, then there's quite some like signal processing going on, and yeah, that's failure cases along the whole line, I'd say.
Yeah, there's tons of places this can fail. And usually, like, I think the hard part is when a developer is working on this thing, they're testing in their quiet room on their laptop, and they configure everything to the speed that they speak at and everything, which when you go to the real world is completely different. We've seen cases where people are tweaking, like, I'll give you an example, a mechanical problem, right? End of turn detection. It's a hard problem to figure out. How do you know when the user is done speaking so that AI can respond? And everybody's also trying to optimize for like fast responses, right? So you want to pick like the right point where you don't want the user to wait for too long. But then we look at some call transcripts in the real world, and you have a lot of people that are just naturally slow speakers. So how do you adapt for that, right? Humans can naturally figure out, okay, this person is speaking slowly. I'm going to wait longer after they take their turn. But when you have a machine that's not really engineered to do that yet, they would cut the user off, and it's a really embarrassing call. And usually those calls end in failures.
Yeah, I can add to Fabian's example, I think. That's where we are starting to collaborate with ai-coustics. Again, with the ambient use case, the recording is really passive. So you don't really think about the recording condition. You set it on your phone, you put it on, and you forget it. Maybe you walk away, actually. It's in the room, but it's very far away. Again, with like reverberation in hospitals, the rooms are not optimized for acoustics at all. So all kinds of suboptimal recording conditions are there for you to fail. And when it comes to different models, the models are not, at least we work with, are optimized to be robust to these conditions. When they fail, they can fail counterintuitively, like something that wouldn't make a human fail might make the model fail just because of a data mismatch.
So for example?
For example, okay, let's enumerate. There's far field, which is putting the phone away and then like talking from where far away. Sometimes we get surprised by the accuracy at which the models do that. But for example, reverberation may not throw off a model, but because it's so uncommon in the training data that the model is just like operating out of domain. And then like something that looks like the model should have gotten right from an intuitive perspective, like human perspective, is not the case from a statistical evaluation perspective. And that's where we're evaluating whether, when we go to a customer, we can pitch ai-coustics saying this is the ai-coustics processed version of your input, and if you run the exact same pipeline on it, here's what you get instead. That's kind of input layer is something that's materializing, I feel.
Yeah, if I don't know, if the input's already shitty, the whole rest of the signal chain is not going to be way better. I've also seen a recent meeting node. I mean, the LLMs can figure out quite a bit. If I sometimes look at it's actually an interesting task or an exercise. If you have a live transcription of your meeting note, for example, in Granola, you can do this, and just you read along while you say something, and often you that's not what I said, that's also not what I said, but then your summary is often good enough at the end. The LLM fixes quite a bit. But we had a recent meeting with a partner, and it fully derailed the conversation, and the LLM kind of got stuck in, I don't know, some conversation it thought it heard, and it was all the wrong information. And I read through it afterwards, and was what did we agree on in this meeting? And it was just like, a massive derailing of sort of like the LLM that was probably triggered by a bit of a wrong ASR beforehand. So it happened. It doesn't happen super often, but it can happen.
There's actually 2 layers to that. In the transcript, you have 2 streams. One is still mutable because like it's trying to give you the lowest latency response possible for what I think it heard, but it still reserves the right to change it before it's immutable. And so what you might be viewing if you pay too much attention to the transcript is that mutable part. But if you take a look at it 5 or 10 seconds later, the potentially corrected version will be there. But that's still the UX. Like if you're trying to get ultra low latency and if there's a different accuracy point for that ultra low latency, that's still the user experience. Like that says the bar.
Yeah, fair point. I'll read a bit slower next time, or like with a larger context window, kind of.
Focus on the meeting.
I always hope that my name gets corrected. Somehow my name always fails.
That's what I'm saying with context engineering. So like the system needs to know about the context because like there might be 7 different ways of spelling a very similar sounding name. And if you're able to somehow say like in the room we have XYZ, 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 you're much more likely to get your name right. So that's the context engineering part of the layer.
I'll still keep waiting.
Let's just repeat the question for the recording.
Okay, so does context engineering help with accents? I think they will help with keywords because keywords are like the scope of context engineering. It's not the entire conversation. So for general vocabulary, you might still see baseline performance. But where context engineering, to the degree that we have been exposed to in the field, is for keywords, for example, if it's industry jargon, if it's names, if it's abbreviations, numbers, alphanumeric kind of portions of the transcript, those are in focus and they may get, I mean, on average, I would expect you to get accuracy for those. But for regular conversation, like regular sentences without those, they may stay the same. I mean, yeah.
In your context engineering, do you use TTS? Like, for example, in TTS, you use English, Indian, English, Arabic, English, like, we usually add those, like, to give a context for our TTS that somebody calls might be, like, Indian English speaker, so we add that accent, right? So do you do that in the context engineering, for example?
Do you mean STT, like the transcription part?
Yeah.
Do you actually mean STT or TTS? I'm
Getting the audio to text, right? That process.
Yeah, but because I was thinking to some cases where if your context has certain words, you may vocalize those words. And there are all kinds of systems that make it both, but let's assume it's just speech to text. I think at that point you're limited by how robust your speech to text model is. Yeah, because what you're doing is you're biasing the model to assume that it's likely to hear certain things, but I haven't seen that happen towards like specifically to accents. But just because of the biasing, it's more likely to do the right thing, even with an accent.
The models have to get a lot better there. I think it's a lack of training data, right? Like a lot of they're very limited in training data, but for people with accents and different type of accents, it's just a really kind of, long tail of data that they don't yet have.
I think that's something also at the enterprise level, when you're scaling to new regions, how do you really make sure that it's able to scale, their agent is able to scale to those new places? And I think we especially see this with India because there's such a massive market there. And they're still not able to, I think a lot of the major models are still not able to handle these different types of languages. And so these different types of languages. And so I think there's a huge opportunity for more geolocalization of models of different systems, et cetera, to be able to handle all these different regions.
Thank you. Great question. Okay, let's jump. We came really close to this next one, which is what does the QA pipeline look like, right? So really, how does it look like when you want to recreate the environments where the customers are, what they're actually using? How do you technically build something reproducible enough to learn from, but realistic enough to expose the same failures?
Happy to start with this one. Because I think this is what we do all day, is how do you build lots of different simulation environments. So I think that's one of the reasons why simulation is so helpful for voice AI, is because unlike lots of other types of agents, actually being able to go back and forth with your agent over multiple turns is really critical for being able to pathfind. So it's one thing to be able to say, for any given turn, what should I say next, is a relatively easy question. I think really the challenge of voice agents is, can I autonomously navigate a changing environment over many turns, especially as your conversations get longer? Can I remember what I'm trying to do? Can I make task-oriented optimizations in order to eventually get to the end? And so that's why having lots of different simulated environments, not only of testing different pathways and different logic trees or different capabilities, but also different languages, different background noises, different accents, different speeds, interruption rates. So that's where we come in, as we will do like highly configurable. Like you can say, I want it to pause in, like, as you're saying a number, I want to have like more interruption rate or less, or I want to change what I'm trying to do mid conversation, or I want to have background noise that isn't just static, but maybe like consistent, someone talking in the background. But one of the hard things about voice AI is when you have all of a sudden it was like quiet, and now someone's talking in the background. These types of spikes are really difficult. And so being able to recreate all of these things that you actually see in production and then sample that and be able to re-simulate it is really important. So I think having, maybe to answer the question actually, is setting up simulation based on calls that you're seeing in production and having this flywheel where you run automated metrics on all of your incoming calls, find the errors, and then be able to rerun those through simulation and create regression sets. That's going to be your best bet for creating a really scalable system, is set of regression tests that you run. As you find errors, you add them to your regression set.
So you said it's a CI/CD for AI, right? So in CI/CD pipeline, we have a lot of monitoring tools like Grafana, Kibana to just like monitor all our like pipelines. So how does translate to AI for your solution when you mentioned that? I'm very curious to know.
Yeah, we definitely pair with solutions like OpenTelemetry or any of these tracing libraries. Where we sit is more at the session level. So we think a lot about like what is your agent trying to achieve over many turns? What is the audio like throughout the entire conversation? Where is your agent going wrong? Where is it going off the workflow? Whereas I think Grafana or like OpenTelemetry implementation or like any tracing framework, you also need and is definitely super important.
Exactly.
But that's going to tell you more of like, what's my latency of tool calls? How often am I calling this tool, but not why am I calling that tool?
Got it. Thank you.
Yeah, I think actually LiveKit, you guys have an awesome tracing library to be able to run, to be able to implement all of this. And so like you can then use Coval like in pair with that of looking at like what are all the traces, how often, like what's the longest latency in my pipeline, et cetera. You can solve that with the like looking through all the traces. And then why was that tool call? Was it called appropriately within context is where we come in.
Okay, we're going to talk a little bit about observability. So I'm going to ask David, you all had a bunch of stuff in the last month about observability. And the question is, how do you design observability that can service the failures that are only visible in production? And I'll broaden it for the other panelists as well. It's just when you see the real world deployments beginning to fail in ways that latency and WER don't explain, what are the other signals that you're looking for, right? So a couple of questions there.
Yeah, so observability is super important. It's otherwise you're like driving blind. You don't know what's going on with your production deployment. And it's kind of different from how we think about software. It's actually a much bigger problem than software, because software is deterministic, right? You write something, ship it, it will behave that way, assuming that, and the inputs are, the scope of the inputs are so limited that it's very hard for users to go beyond that scope. But when you deal with an autonomous voice agent over multiple turns, it's like every conversation is different. Right? I look through all these sessions that our customers submit to me, and there's it's edge case upon edge cases that you're going to discover. So like our approach to observability is really like you want to look at not only traces, but traces along with the conversation, and having the transcript and the audio. The raw audio is where you always start, because ultimately that's what the native inputs and outputs that your system is producing, right? So you need that information. But then you also want the ability to correlate that with what your application is doing. So kind of drawing that connection, and your application is emitting traces, doing all these things. And we kind of initially partner with third-party solutions for observability, Grafana, et cetera. But really ended up finding out that like the user experience of getting to the root cause of the problem is quite difficult. So we kind of had to tie all these different things together inside the LiveKit dashboard, where you can kind of see audio transcripts, logs, and observability traces. But I think that's the passive part that's like discovering the issues, and then how do you actually ensure you can fix the issues? That's, I think, where Coval comes into play, of really running simulations and validating that, hey, these failure cases I've seen before, are actually result. You're actually improving the quality of the application. And so really, I think, if we think about 2025 as a year of like agents going to production, 2026 next year is really kind of the year of agents become reliable, right? Like, so I think many companies are really focused on this problem of increasing that reliability bar, and observability is a key part of that.
I just had a question overall. A lot of the conversation has been about audio, taking voice and turning it into text, passing the text to the LLMs. And this year there was a lot of multimodal models which take raw audio with all the nuance and all the emotion, all that good stuff that gets lost in a transcript, as does speaker identity and all these other things. So is there an evolving standard so as you reduce to text, you can reintroduce that new nuance that the multimodal models understand? I'm just really curious how that's going on the audio layer.
Yeah, that's a great question. I think this is like the dream, right? Can we feed audio in and have the brain have all the context and all the information and spit something out that's intelligible? I think it will happen, and people are already doing that in a lot of these different use cases. The difficulty, I think, really comes back to reliability, right? Like when you're talking about what's actually important for many of our customers who are building business use cases is the reliability. How do I make sure it's doing the simple job? Yes, it's okay if it misses a bit of information, but I want control and be able to steer the model and not have the model behave in unpredictable ways. So I think the big challenge the industry is solving with the speech-to-speech is that when you open the input scope and kind of have the model do so many things at the same time, you also give up some control, right? Audio models don't call function calls as reliably as text models do. So that's kind of one downside. And because the audio models are multilingual, sometimes they actually start speaking a different language, right? Their edge conditions that trigger that. And business customers don't really want those behaviors. So for now, I think they're just like, okay, let's stick to the reliable, boring, we may lose a bit of information. But I think to your point, like we do wish to see some of the richness. Like there are experiments in terms of like what we call a half cascade. A lot of companies are experimenting with it, which is taking a multimodal model, it's a mouthful, and have it produce text output. So then you can do more with the text output, including seeing how the emotion the response emotion should be, and injecting it back into the model.
Actually, I think recently this effect was quantified by a benchmarking firm called Artificial Analysis. They have a controlled benchmark where it's the same task, but the input could be audio or text, but the benchmark is the exact same task, like in terms of like what the model is being asked for. And I think GPT-4o was like one of the models where if you ask the same question in voice versus in text, there was a huge gap in what the output was with the exact same API. And so I think the first generation of these end-to-end like speech-to-speech models under-delivered. It doesn't say too much about the next generation. I think we've always been delighted by the next generation of models so far. But I put my weight behind modular approaches, so like speech-to-text, LLM, and if necessary, text-to-speech, just because there's modularity. If one of the layers improve, you can adopt that improvement in a modular way. And if you are tuning your prompts, if you have a very specific downstream behavior, you can keep having control over that, versus if you have to end-to-end adopt a system, you have much less control on, like, I would say, steerability. But next generation might bring completely different capabilities, so I don't want to be proven wrong very soon.
But you're talking about next generation, so that's our last question. So we're going to jump in. David, you talked a little bit about your prediction for 2026. Basically, paint a picture. And what I want ideally here, because we're getting a lot of predictions. If you open up LinkedIn, everybody's predicting everything. So what I want is, think of a customer story, someone like a hero, somebody that becomes a hero because of something that develops in 2026. Right? That would not be possible right now, but because of what happens in 2026, that becomes really possible. So process that for a moment. I'm going to start with Fabian because that's the easiest one.
Is it?
Yes.
I mean, that's not so much of a, I mean, maybe I myself, I'm a customer, but like I would be happy if by the end of 2026 I have more voice interaction with my like laptop or phone than I have like text interaction. I mean, currently I think I'm like, most of it's still like, typing in, but like if I so like myself see that, it's always a good, measurement if I sort of like start using voice more, obviously, as an interface. And then, I mean, I don't think that's a very like drastic kind of like prediction, but what you mentioned earlier, that the whole we've seen a lot of like proof concept prototypes, also people using it in production quite a bit, but how do things really get so reliable that this becomes more towards like mass adoption is something I'd really like to see. And then voice itself as an interface unfolds a lot more. There was actually an interesting meetup here in October where it was more about like physical AI and how do we interact with machines in that way. And I think this is a I don't think that's a 2026 thing, that's a bit like later, but like how do we then interact with machines and on a more like not physical level, but like machines that have a gestalt kind of like themselves. And that, especially for us, is super interesting because like that's an even more difficult acoustic problem when like three people talk to the machine and the robot in, an environment like this, and there's a PA included and whatever. So yeah, but that's a bit further down the line. Sorry.
I think based on customer story, I guess, is probably the most interesting. So we work with like large public banks, and one of our customers, I think, is moving more into actually taking actions on your behalf in order to achieve something that you want to do with your account. I'm super excited about that because I think one of the most frustrating things is you call a voice agent and you're like, I know what I need to do, and I've already realized that I can't do it some other way, and I just need you to like do some action on my behalf. And so I think the more that we're going to start to see voice agents be able to take these things like account reset or some like verification and these other types of like, taking action on your behalf is super exciting, because I think it's going to flip the switch from I'm annoyed that I'm talking to an IVR, and now actually I can pick up the phone and do some action that otherwise I have to search around some web app on my computer and it's going to take me a while. And this just solves my problem within 30 seconds and now I'm done. I think that will really start to flip the switch of people like talking to voice AI in the same way where I think early internet people would say, why would I ever buy something online? I would never put my credit card into a web application. And now people don't want to go, like, I never want to go to if I cannot go in person, that's ideal for me. And I think we're going to see that switch with voice AI, maybe not next year, but hopefully in the next, let's say 3 years.
Fun fact. Earlier, Fabian was looking for something and he was like, where do people buy stuff here in San Francisco? Has everybody just relied on Amazon deliveries? And I'm like, I could not remember where to get an electronics thing because we're just so used to it. The tripod, yeah, thank you. I told him, I think there's a Best Buy. I don't know if that still exists.
Fry's Electronics.
Fry's Electronics, these places. So very much. Atila, predictions for 2026?
Mine is similar to Fabian's. Beginning of this year, maybe it's fair to say, I was not using any voice product in my professional life or personal life. At Argmax, we have a culture of living on customer products / I guess other people call dog fooding. When we're in the loop, we want to make sure everything is working as expected in a regular user's workflow. So when I enter a meeting, 5 different AI meeting notes apps ping me whether they should start recording or something. I have 3 different iOS custom keyboards now. All of those are forced because I want to test them, but I'm sensing a shift of this is actually starting to become compelling enough for me not to push myself, but actually organically use it. I hope the barrier is not far away, because I might not be an early adopter person myself naturally, but I'm forcing myself to be. So I think our customers are selling to early adopters in 2025. I hope it's mainstream is the market in 26. And for that, a bunch of things need to improve.
I'll just give my story. My dream for 2026, I speak Spanish and English I switch from one to the next. And no, I can never get the transcript to work correctly. And it's just really odd for me when I'm using an iPhone that I actually have to switch that I'm now going to be doing Spanish. I would think now it would be able to know that I'm speaking Spanish. And I just find that incredibly annoying. Sorry, I'm just sharing that. We can try it after. It does not. Okay, so we're going to open it up for a few questions. Aida, I just want to out you. She works for Vonage. A lot of great questions, so thank you so much. Fantastic. Are there other questions, please? And we're going to give you the microphone just so we can capture the questions. And please tell us a little bit about yourself so we can capture that as well.
So I'm Philippe Szymański, and I'm building voice AI for healthcare, starting with dental. So next time you call and schedule an appointment to get your cleaning for your teeth, could be my voice AI. Okay, so anyway, that's the pitch. So I was meeting with prospect earlier this week, and he asked a good question. I probably don't have enough customers to answer it, but maybe you do. And basically he asked, okay, this is a phone-based use case. You call the dental office or whatever healthcare provider. How many of the patients hang up on the voice AI or immediately demand a human versus how many actually engage, even potentially complete the use case successfully? What percentage? Because that was their ask, right? Because if they thought if it's only 10% complete the use case, 90% hang up, why bother with it right now? So I'm just curious, what are you seeing?
And I have a related question after that.
Yeah.
Sure. I think it's where this number will change, right? Depending on the use case. For example, if you're hey, would you like to talk to our AI agent right now or wait 10 minutes for the next human rep? You're not going to get people hanging up on you anymore, right? So I think the number is, honestly, some customers are actually seeing that users prefer to talk to the AI because it solves their needs a lot quicker. If it's simple enough, they're not having to do a lot of things. I know we have a customer in the audience who's having a lot of success. So Zaf from Yelp has built this, AI assistant for small businesses, right? So imagine if you're a plumber, you can't get to the phone and talk to your agent. I don't know if you're happy to share what numbers you're seeing, but I think people are, I've met people that have used the service as a customer and really loved it. So I think this is one of the, we're in the phase of, if you ask the question of why are they hanging up on them, it's really because they've had a bad experience, right? The caller is trained that AI bots suck and are a waste of time. So that's why they're behaving that way. But if they have a few positive experiences, that number you're going to see kind of increase.
Yeah, I think the context matters, but beyond that, also the voice matters a lot. So, like, if we first launched at the Oh, sorry. Yeah, I do voice AI at Yelp. So, but they like when we first started, this was like a year ago. We were on the OpenAI, and when we OpenAI voice to voice, and then like in May we had like a live use case, was a customer service one, and then that one, I think we were seeing maybe between 60 to 80% where they would ask for a human right away. When we switched that over to the next model we use for text to speech, we sounded way more human. It went from 80 to 0. Like the number of people who wanted to transfer within the first like minute and a half kind of thing.
Are you going to tell us what it was?
Cartesia.
Oh, Cartesia.
Yeah. So that was our model, but not Cartesia's vanilla voices. We cloned our own. So they sound really human. You won't be able to tell it apart. So.
Anybody?
Sorry, I work with a lot of healthcare customers, and I just want to emphasize that voice AI is just one part of the whole system. So when you're looking at the system, you have to look at the collectively of everything. If your IVR is trashy, if even the voice is crisp, they're going to hang up on you, right? So if you just do the pound and it doesn't just redirect you to the next action, they're going to hang up, So, or if they ask you wrong questions, they're going to hang up. So when you're building the IVR system, you have to look everything from the, like a little bit of the, just not the narrow lens, but you have to take your lens a little bit farther and just look at everything that has to work perfectly, plus your voice AI. So if you have a perfect voice AI, but bad IVR, they're going to hang up. Just want to just say that.
Many of you work with, my name's Henry. I run the Voice AI program at CloudTrucks. Many of you work with enterprise clients. I'm curious, not the CTOs, but the CEOs and ROs. What are they thinking about in Voice AI, and what trends are you seeing in terms of themes that are more resonant to folks who aren't as excited by the technical problems of voice?
Yeah, so the question is kind of like what makes people excited about voice on the ROI side of like where are we seeing the largest ROI? I think definitely moving away from I think everyone's biggest question is how do you move away from being a cost center and into creating user value or like creating a better product experience. So any opportunity where you can take a customer service experience where maybe things were going poorly, but now use this as like, one, can you make their average handling time? It's like, can you reduce the amount of time that like the person has to deal with you on the phone? But I think even beyond that, like the future of really amazing voice AI is how do you create an experience where they're like, oh, it's really easy because now, like similar to the web and mobile era, now you would like never fly an airline that doesn't have a good mobile app or a good website. Like if you had to call the airline to book your ticket, that would be insane. And I think that we're going to see the same thing happen with voice, where I just expect that my bank has like really seamless voice interactions, or I just expect my airline, I could say like, hey, I'm like running late to the airport. Are there any other flight options? And not have to sit on the line for 20 minutes. And so I think that's really going to be where you take it from being a cost center and just a like pure ROI calculator, but turning it into like a core part of their product. I don't know if that answers your question. But then other than that, definitely moving like the highest ROI cases, if you are like a cost center, is really like when it's highly skilled labor and you have to like have a lot of knowledge and a lot of expertise on an area with like very high value experiences is going to be really different than like super high volume that maybe is outsourced to the Philippines. Those are like, there's a lot of range in terms of customer support.
Yeah, I could. Maybe less relevant, I guess, but we are the deployment layer. So before we come in, the enterprise customer would already have a cloud deployment of their product, and they would have a certain scale. Maybe they're ramping up. They may have already iterated once or twice. So they're figuring out the story there. The way we come in and how the CEO thinks about it is scalability from a cost efficiency as well as infrastructure reliability perspective. Like when you serve to 10,000 users, you have a different infrastructure challenge. When you sell to 1 million users, it's a different infrastructure challenge. Auto scaling wise, like uptime wise, all that stuff, multi-region wise. So one reason we resonate is on the edge. By design, you do a lot of things like auto scale, like 100% uptime as long as the app is up, your inference is up, all that stuff. But just because we operate at a lower level, like all the modeling ROI, the feature ROI, like how they're going to market with voice AI is like, that already happened upstream of us.
So we'll take one more question, then we'll break.
Yeah, just for anyone, maybe, have you heard of...
Can you introduce yourself?
Sorry?
Can you introduce yourself, please?
Yes, of course. My name is Max. I'm with Max Health. I'm also in healthcare, yeah. I have a question. Maybe you've heard of Gibberlink. If so, do you think this has a future, and have you thought of how to quantify sound as part of your solution?
Can you expand on the question a little bit more? Sorry.
Gibberlink, it's like the idea of how to explain, like non-human language that is being used for transmitting information via audio. Yes.
I just have a strong opinion on this. I don't know if it's an industry, but I think that people are like, oh, if machines could switch to a more efficient language, but humans have been developing language for thousands of years, and it's actually really efficient at being able to capture all sorts of signal and express a whole range of basically everything you're trying to say. So I would say human language is pretty efficient and pretty expressive. So why use another?
It's an unusual question. I'm sorry, yeah, but anyone who hasn't heard of it, it's like it came from a hackathon originally, but it's like it became a meme that you can let two AI speak with each other, but in a robotic language to make like modem sounds. Yes.
Yeah. Yeah, hello. This is actually my first time hearing about this, but I think it's a super interesting idea. And to your point, I feel like, human language has been evolving for, a lot of time, but I feel like a fundamental constraint that has shaped its evolution is like neural capacity, how much information we can make sense of within a specific amount of time via the audio medium. And so if, say, you're talking about, for example, text LLMs can read text at a pace that's way faster than humans can read text. And so like transferring that logic over to audio, if you have machines that can understand, make sense or process information through the audio channel way faster than our brains are capable of, then if you have a language that's able to more efficiently use that channel, there'll be promise in that. That's just something that occurred to me.
So maybe we'll be thinking about that in 2027. I'm going to wrap it up. We want to encourage everybody to stay. There's a lot more food down there. I did want to thank our panel. Thank you very much. And I wanted to thank the folks here at Frontier Tower. Thanks to Nell from our Berlin team who helped put it all together, and the recording, Jenny from LiveKit. Now, you all have received these, what I found out they're called bum bags. If you have not opened them, you will find some stickers, but there's also a little piece of chocolate from Germany there. So enjoy that. Thank you to Nikhil, who's been helping us there on the soundboard. Lois has left already. We'll do this again in 2026. This is the audio layer. Thank you very much.